Hello all and welcome to the course Fundamentals of Electrical Engineering, and this is we are now into week number 6 of this course. Let's first go through the brief summary of week number 5. We were talking about circuit analysis techniques. We had already covered nodal and supernode analysis techniques, and in the last week we covered mesh analysis technique, and we a brief overview of it that it is based on Kirchhoff's voltage law, which is usually abbreviated as KVL, and it gives out the value of loops current. Basically, it forms a series of simultaneous equations in the form of mesh currents, and then by solving them, you can find out the value of mesh currents or loop currents. And super mesh analysis is performed when there is a scenario that a current source is present between more than one loops. This forms the case of a super mesh, and it is solved by open circuiting that particular current source. And once you have open circuited that current source, then you are short of equations, and those equations are found out by applying KCL to that particular node involving the current source. Right? We also covered the examples of mesh analysis and super mesh analysis in the previous course. So in this week, talking about week number 6, we will be covering circuit theorems in week 6 and 7. First of all, the first circuit theorem that we will be covering is superposition theorem, and then we will be covering source transformation theorem. We will be covering these two theorems in this week, that is week number 6, and then Thevenin's theorem and Norton's theorem we will be covering in the next week. So coming towards the superposition theorem basically is applicable to linear circuits only, linear quantities only. And what does it say? It says that if you have a circuit involving multiple sources, there are a number of sources in the circuit, then one way or one method to solve that circuit is to consider only one source at a time and find the individual contribution of that particular source only, right? And continue doing that for all the sources, and in the end you just need to add up the individual contributions of all the sources to find the net contribution or the net value of the particular parameter, that is voltage and current across a circuit. So what does it say is that the voltage across or the current through any element in a linear circuit is the algebraic sum of the voltage or current due to each independent source acting alone. This is what we have discussed. One thing is important, that this theorem is only applicable to linearity scenarios. That means it is only applicable to voltage and current scenarios. Why? Because they are linear as per the Ohm's law. But when we are talking about power is equal to the square of current times the resistance, I square R. And since there is I square involved, that means power is no more a linear relation in a linear relationship. So you cannot apply superposition theorem for calculation of power, right? It is only applicable for linear quantities only. So the steps which are involved in solving a circuit through superposition theorems are that first of all you need to analyze the circuit, how many sources are present in it, and then you need to turn off all the independent sources except one single source. And we know that if we are turning off a voltage source, then we need to make its magnitude equal to 0, and the magnitude equal to 0 is the characteristic of a short circuit. That means we need to replace the voltage source by a short circuit. On the other hand, when we are talking about a current source and we need to make its magnitude equal to 0, this is the characteristic of an open circuit. So we need to replace the current source by an open circuit. The next is find the output parameter, whatever is required, the voltage or current due to the active source. Here it should be source because we are considering one source at a time, right? By applying any circuit analysis technique, you can apply CDR, you can apply VDR, you can apply series parallel combination, nodal, mesh, supernode, super mesh, any technique of your choice, right? And then you need to continue the above two steps for all the sources present in the circuit, right? And in the final step, you need to add the individual contributions so that you can find the total contribution, right? So let's move on towards a few examples of superposition theorem. Okay, now let's move on towards a few examples of superposition theorem. The statement for the question is that find the voltage V0 using superposition theorem. And here is the circuit for this question. Okay, so here is the circuit for this particular question, and in this circuit, as you can see, we have two independent sources. The first one is the source voltage source, which has a magnitude of 6 volts, and the second one is the current source, which has a magnitude of 3 amperes. And if we go through the steps of superposition theorem, then we can see that the very first step is to turn on only one independent source at a time, right? So first we will write according to the superposition theorem. According to the superposition theorem, V0 is the sum of V01 plus V02, right? Where V01 and V02 are the voltages due to 6 volts and 3 ampere sources respectively, right? And now what we will do, we will consider only one source at a time. So we will be considering the 6 volt source only, right? Now our circuit will look like this. This is a 6 volt source, right? 8 ohms resistance, and then we have this 4 ohm resistance, and the voltage across this branch is now V01. We have ignored the 3 ampere current source, and we know that since it is a current source, in order to remove or negate its effect from the circuit, we need to make the current from this source is equal to 0, and the current is made is equal to 0 by open circuiting that particular branch, because in case of an open circuit, the current is equal to 0. So once we open circuit the 3 ampere source, you can see here, now we can see that once we open circuit this source, this complete path will have no current, right? So our remaining circuit will be like this, as we have shown, as we can see here, right? Now another thing that we can see is that this theorem only gives an idea how to solve the circuit, right? V01, that is the value of voltage across the resistance of 4 ohms due to the independent voltage source of 6 volts. This voltage still needs to be calculated by the help of the circuit analysis techniques that we have discussed previously. We have learned various circuit analysis techniques in the previous lectures. Like we have already learned what is voltage divider rule, current divider rule, Kirchhoff's voltage law, Kirchhoff's current law, and nodal analysis, super node analysis, mesh analysis, and super mesh analysis. So we will be applying any of these techniques here, and this is up to you people to decide which of the technique here gives the best answer or gives the answer in least number of steps, right? Here, as you can clearly see in this question, we have a voltage source that is connected in series with two resistances of value 8 ohms and 4 ohms, and we need to find the voltage across one of the resistances. So the best method to apply in this particular case is the voltage divider rule, because it directly gives you the voltage across the resistances, right? So we just want to apply voltage divider rule, that is VDR in this case. So just write applying VDR, and now since we only want to calculate the value of one resistance, so there is no need of finding the value of one voltage. So there is no point in finding the value of voltage across the other resistance. So we will solve this circuit as V01 is equal to, we know that in case of voltage divider rule, the resistance across which the voltage is being calculated comes in the numerator, which means 4 ohms, and in the denominator comes the sum of resistances, that is 8 plus 4, right? And then comes the total voltage, which in this case is 6 volts. So V01 will be equal to 4 divided by 12 multiplied by 6 is equal to how much? It will be equal to 2 volts. So this is the value of V0. Now we have calculated the value of voltage due to the which is the contribution by the 6 volt source. Now we need to turn off this 6 volt source and calculate the value of voltage which is due to the presence of 3 ampere current source in the circuit, right? So what we need to do is here we need to consider the 3 ampere current source only, right? And now what we need to do with this voltage source, we need to turn it off, and the voltage source is turned off by making voltage is equal to 0. That means replacing it with a short circuit, right? So we replace this voltage source with a short circuit. Then comes the resistance of 8 ohms, right? Then we have another resistance of 4 ohms. This voltage will now be V02, and finally we have a current source of 3 amperes, right? Now again what we need to do, we need to find a suitable circuit analysis technique by which we can find V2, right? There are different methods. The method that we will be going to apply is that we can see that 4 ohm and 8 ohm resistances are now in parallel. Why they are in parallel? They have two nodes in common. Which two nodes they have in common? This is the first common node and this is the second common node, right? So these two nodes are common between the 8 ohm and 4 ohm resistances, thus making them parallel to each other. So that means the CDR, current divider rule, is applicable in this case. So applying CDR, we are only concerned with the value of 4 ohms resistance. So the current, not the voltage, because we are applying CDR, current I naught 2 will be equal to how much? Because in CDR the value of the opposite resistance comes in the numerator, that means 8 divided by 8 plus 4 multiplied by how much? 3, right? The total current. So that makes 8 over 12 multiplied by 3, 4 times of 3 is 12 and it's 2, right? So it will give you 2 amperes. But the important thing is that we should note, we have calculated the value of current, whereas we need the value of voltage. So again we need to apply Ohm's law and calculate the value of current through this branch, the value of voltage through this branch with the help of current, right? So according to Ohm's law, V is equal to IR, we all know that. So V naught 2 is equal to I naught 2 times the resistance. So it will be I naught is how much? 2 multiplied by 4, so it will be 8 volts, right? So we have got the value of V naught 2. So V naught itself will be equal to V naught 1 plus V naught 2 is equal to 2 plus 8. So the total voltage here in this question is equal to 10 volts, right? I hope this question is now clear. Let me repeat it step now. First of all, we were given a question where we were required to calculate the value of voltage V naught given the with the help of superposition theorem. If superposition theorem was not mentioned in this scenario, we could have applied different techniques. We could also have applied mesh analysis. We could have applied nodal analysis to find the value of V naught. But since it was mentioned in the question that we need to solve it by using superposition theorem, so we need to consider one source at a time, right? We can also make it equation as equation 1, right? What superposition theorem says that the voltage across any element or any branch or the current through any branch can be found out as a function of this or as an addition of individual current or voltage contributions by each independent source, right? So first we considered the 6 volt source and turned off the 3 ampere source, and when we turned off the 3 ampere source, then the resistances of 8 ohms and 4 ohms became in series. Why? Because they have one common point and there is no other source connected to that point. We can also name these resistances as R1 and R2, right? So this is turned out to be our main equation, and then R1 and R2. So if we just write it as, so V naught 1 will be equal to R2. Why? Because we are talking about the voltage across this branch divided by R1 plus R2 multiplied by Vs, that is the source voltage. So we put the values here, found out the value to be 2 ohms. Clear? Then in the next step we considered the 3 ampere current source only. Here it is R1, here it is R2, and turned off the 6 volt source, which means that now the resistances R1 and R2 are in parallel, and we know that when two resistances are in parallel, then the current divider rule is applicable. What does current divider rule say? That I naught was equal to the resistance for which we were not considering the current, that means the 8 ohm resistance. So it was I1 divided by R1 plus R2 multiplied by the total current or the source current, right? So solving it gave a value of 2 amperes. Then with the help of Ohm's law we calculated the voltage, and the total voltage in the circuit due to the presence of both the sources is found out to be how much? It is found out to be 10 volts. So let's move on towards a second question or a second practice exam problem of this topic, and again the question is same. Find V naught for the given circuit using superposition theorem, right? And let me draw the circuit. Right, so this is the question, and we are asked to calculate the value of voltage V naught due to the contribution of both the sources, and since we are required to solve it by superposition theorem, that means we need to consider one source at a time, right? So first of all, let's name the resistances as R1, R2 and R3. We have again a voltage source of magnitude 20 volts and a current source of magnitude how much? It is 8 amperes. So let's write it according to superposition theorem. V naught is equal to V naught 1 plus V naught 2, name it as equation 1, where V naught 1 and V naught 2 are the voltages due to 8 amperes and 20 volt sources respectively acting alone, right? So now let's consider one source at a time. Just encircle or border this main equation, and considering 8 amperes source only, right? So now we are considering the 8 ampere current source only, so which means that this voltage source will be short circuited. This is R1, this is R2 and this is R3, right? So now we can to calculate the value of which one, we need to calculate the value of voltage V01, and again we can apply various techniques. The most easiest technique, or the technique that comes that is applicable here, is that we can see that these resistances R1 and R2, they are in series with each other, and if we solve them in series, then their equivalent resistance, let's assume it to be R4. R4 and R3 will be in parallel. R4 and R3 will be in parallel, which means that we can apply CDR, right? So another method to solve this question is of course to apply nodal analysis. This will be node V1, this will be node V2, and this complete will be the reference node. So you can also solve that, no issue in that, and the answer will also be same. You can even try solving it by different methods, so and check that the answer is same. So thus it will act as a proof for different circuit analysis techniques, right? So just simplify this circuit, and we can write as R4 is equal to R1 plus R2 is equal to 2 plus 3 is equal to 5 ohms, right? And now if we draw the circuit, it will be like this: 5 ohms, and 5 ohms, right? So it will be 8 amperes, and this is how much? This one is, we have now named it as R4, and this one is R3. Now you can clearly see that R4 and R3 are parallel. Why? Because they share two common nodes. This is the first common node and this is the second common node. So since they are in parallel, we can apply CDR, right? So applying CDR, just wait a minute, let me so applying CDR here will give what? I4 is equal to the opposite resistance, right? That is R3 divided by R3 plus R4 multiplied by the source value. So it will give 5 divided by 5 plus 5 multiplied by 8. So it will give a value of 4 amperes. Now you can see that we have calculated the value of I4, which is the current through the resistance R4, right? This will be I3, which is of no use to us because we are only worried about calculating V01. Now here you can see that V01 is actually R4 is actually the series combination of R2 and R1, and once we know the value of current I4, right, we know that in a series combination the current remains the constant, right? So by the help of Ohm's law we can calculate the value of voltage as V is equal to IR. And you should also note that now the current is moving in this direction, which means this is the direction of current I4, right? So the current is entering positive terminal. You also need to check the polarities of current here, right? At the moment we have solved this value which is 4 amperes, and now we know that R1 and R2 are in series, so the current will remain the same. Or in other words, you can see that this particular node has no path for flow of current. So the current which is flowing through 3 ohms, the same amount of current will be through 2 ohms, and we know that according to Ohm's law. So just okay, so according to Ohm's law, V01 will be equal to I4. Here you can see I4 multiplied by R1. So I4, since it is entering the positive terminal, will be positive. How much is the value of I4? It is 4 amperes. Multiply by R1. How much is the value of R1? It is 2 volts, 2 ohms. So V01 is equal to 8 volts. Clear? V01 is equal to 8 volts, right? So we have found out the value of, or the contribution due to the due to which source? Due to the current source. And now we will be considering the voltage source. So let's write considering only the 20 volts source. So our circuit will become, when we are considering the 20 volt source only, which means that we need to neglect the impact of this 8 ampere source. And how do we neglect the impact of this 8 ampere source? We need to open circuit it. That means this complete branch will be removed from the circuit. Why? Because there will be no current through this branch. So let's redraw the circuit. 2 ohms, 3 ohms, 5 ohms, and 20 volts. V02, right? So our circuit will now look like this, and we need to solve this circuit. Now again you can see here that the circuit here, you can see this is a series combination. This is a series combination of resistances. So when we are solving this series combination, just we can write it as R1, R2, R3, right? So we can just solve these two. Okay, so let's apply VDR here. We can apply, but for that we need to simplify the circuit a bit. Let's make it as R5, 20 volts, and 2 ohms, which is the same R1, right? R5 here is equal to the sum of R2 and R3, which is equal to 5 and 3 ohms, so it is 8 ohms, right? So according to VDR, now applying VDR, V02 will be equal to how much? V02 will be equal to R1. Why? Because we are calculating the voltage across resistance R1 divided by R1 plus R5 multiplied by the source voltage. So that makes 2 divided by 2 plus 8 multiplied by 20, right? So that is equal to 2 divided by 10 multiplied by 20. So V02 in this case is equal to 4 volts. And if we just recall equation number 1 that we have previously formed, equation number 1 said that V0 in total is the algebraic sum of V01 and V02. So V01 we found out to be 8 volts plus V02 is 4 volts. That means in total the voltage, desired voltage, is how much? It is 12 volts. So I hope that this is clear now. Okay, so now let's move on to a third example, and this will be the last example for this topic. The question says that using superposition theorem, find the current I for the given circuit, right? So let me draw the circuit. Okay, so this is our circuit, and we need to find the value of current I, which is actually the current through this resistance, the 8 ohm resistance, and it is mentioned in the circuit. Now we can see that this particular question is slightly different from the two we have previously solved, because the previous questions involved two sources, but here this question involves three sources. There are two voltage sources, two independent voltage sources of magnitude 16 volts and 12 volts, and then we have a current source which has a magnitude of 4 amperes. So let's start it. First of all, since we are bound to solve this question using superposition theorem, so let's write according to superposition theorem. According to superposition theorem, the current I is equal to the sum of I1 plus I2 plus I3, right? And let's name this equation as equation 1, where I1, I2 and I3 are the individual contributions due to 16 volt, 4 amperes and 12 volt sources respectively. So first of all, we need to consider one source at a time. So let's consider the 16 volt source and ignore, or not rather ignore, but rather turn off the other sources, that is 4 ampere source and 12 ohm source. Let's name the resistances as R1, R2 and R3. So let's write considering only 16 volt source considering only the 16 volt source, so this 4 ampere source will be removed. That means the complete branch will be removed, but this resistance will be present. Why? Because they are in parallel. The 4 ampere branch will only be removed by open circuiting, and this voltage source will also be short circuited, replaced by a short circuit. So let's draw the circuit. 6 ohms, then we have 2 ohms and then 8 ohms. Right, so this will be our circuit, and here you can see this will be the current I naught 1. Now the easiest way to find this current I naught 1 is by which method? Let's think different methods that we have discussed, and the easiest way is to find it via mesh analysis, right? This is our mesh. The current I naught 1, there is only one loop in the system, so this current I naught 1 is flowing through the system, right? Let's assign the polarities and applying KVL to the mesh. The current is now entering the negative terminal, so it will be minus 16 plus V is equal to IR, right? The product of voltage, voltage is the product of current and resistance. So plus 6 times of I naught 1 plus 2 times of I naught 1 plus 8 times of I naught 1 is equal to 0, right? So that makes 6 to 8 and 8 and 8 16. 16 I naught 1 is equal to 16. Thus I naught 1 is equal to 1 amperes. So now we have found out the value of, or the contribution of one source, right? So now consider the second source. Here we can see that the second source here, let's consider considering the 4 ampere source only, and when we are considering this 4 ampere source only, then both the voltage sources, right, at the moment we are considering this source, both these voltage sources will be short circuited in order to negate their effect. So let's redraw the circuit. 6 ohms, this is, and this is how much? 2 ohms. Four amperes. Eight ohms. And this will now become I2, right? Rather I2, yes. Or even we can name it as I naught 2. So just name it as I naught 2, it will be better. Now we need to think of which method will be better in this case. So again you can see that here in this scenario the series parallel combination method will be more easy, or will be comparatively easier. Why? Because we can see that R1 and R3 are in series, and then they are equivalent. First let's solve R1 and R3 in series. Why? Because they share a common node and there is no other element connected to this common node. So let's solve them. Okay. amperes. This will be R4 is equal to R1 plus R3 is equal to 6 plus 8 is equal to 14 ohms, right? Now we can see that R1, this R2 and R4, they are in parallel. Why? Because this is the first common node and this is the second common node. They are connected between two common nodes, so they are in parallel. And once we find the value of R4, right? Once we find the value of current R4, then the current will be the same in R1 and R3. Why? Because they are the series combinations. Okay, so applying CDR here, will give the value of, this is the current I02, right? So I02 is equal to how much? The opposite resistance was, that is R2 divided by R2 plus R4 multiplied by IS is equal to 2 divided by 2 plus 14 multiplied by 4. So that gives you the value of I02 to be 0.5 amperes, right? So I hope it is clear now that I02 is equal to 0.5 amperes. And since R1 and R3 are in series and their equivalent is R4, so that means the current which is flowing through R4, the current will be same in R1 and R3, as you can see in the picture. Now coming towards the third source, which is the 12 volt source here. So in order to consider its effect, we need to turn off this 4 ampere source by open circuiting it. Why? Because it is a current source. And this 16 volt source by short circuiting it. Why? Because it is a voltage source. So considering 12 volt source only, so this makes our circuit like this. We have 6 ohms here, then we have 2 ohms, 8 ohms, and this will be the current I03, right? So now you can see that the easiest way out to solve this question is by the help of mesh analysis. This current is flowing in a complete mesh or loop. This current is I03. So let's apply KVL to the loop. Applying KVL to the loop, it will give, first of all, here plus minus plus minus plus minus plus 6 times of I03. Why? Because voltage is the product of current and resistance. The current is entering the positive terminal, so the positive sign, and 6 is the value of resistance and I03 is the current. Then again plus 2 I03 plus 8 I03 plus 12 volts. Here you can see that the current is now entering positive sign, so it will be plus 12 is equal to 0. 6 to 8, 8 and 8 16, right? So 16 I03 is equal to minus 12, so that makes I naught 3 is equal to minus 12 divided by 60, right? So the answer for it is minus 0.75 amperes, right? Minus 0.75 amperes. And now since we have got the values of all the currents, so we know that as per equation 1, the total current I is the sum of I1, I2, I3, or since we have named them as I1, I01 plus I02 plus I03, so it will be the sum of I0. What is the value of I0? The value of I01 is 1 amperes, right? Similarly, the value of I02 is 0.5 amperes, right? So 1 plus 0.75, sorry, 1 plus 0.5 minus 0.75, so the final answer will be I is equal to 0.75 amperes, right? So this is the final answer for this question. So I hope it is clear now what we have done and how we have solved this question by considering 3 different sources, only one at a time. So that concludes our topic of superposition theorem, and in the next video we will be covering the topic of source transformation. So this topic here, I hope it is clear now along with the examples.